Hello, I'm Alex Harmon and this is a video on the Gale-Shapley algorithm. The Gale-Shapley algorithm is designed to solve the stable marriage problem. In this problem you have two sets, which we're going to call male and female for this video, that don't intersect. That means that there's nobody in here who is both male and female. There's also nobody who is neither. Each male has an ordered list for which females he most prefers and vice versa for the females. This means that every person in this algorithm has a list ranked from 1 to however many of the opposite gender there are in this set. This list is strictly ranked, which means that there is person 1, 2, 3, 4, 5, 6, 7, 8, 9. Nobody is ranked the same. Nobody is left out of this list either. The list will also vary from person to person, so if you have two guys, Fred and Charlie, Fred's list might be different to Charlie's list, although they have the same people that will be ordered differently. This also applies to the females, they'll have their own ordered list as well. There are also an equal number of males and females, so nobody gets left out. The Gale-Shapley algorithm aims to find a stable matching. Here's a matching here, you can see the females on the left, the males on the right, and it's a 1-to-1 mapping, so that A only likes 3 and 3 is matched to A, and that's it. The matching is not stable if there is a guy and a girl who are not matched, and they each like each other more than their current match. The rules are formalised down here in the bottom right a little bit more. So, here's an example of a ranking for the females. On the left here we have eye patch girl, hat girl, black haired girl, and blonde haired girl. And as you can see, they each ranking, left is the most favourite, right is the least favourite. We've got blonde guy, we've got black haired guy, we've got moustache guy, and we have eye patch guy. As you can see, eye patch girl likes blonde haired guy the most and eye patch guy the least. Hat girl likes eye patch guy the most and blonde guy the least, and so on. And here's the ranking for the guys. Moving onwards, we're going to look at see if whether this matching here is stable. So we've got hat girl and eye patch guy matched up, black haired girl and black haired guy matched up. We've got the rules down here to refer to, and we've got the rankings on the top right there, so we can check those. So moving down the list of females first, because they're on the left. Eye patch girl really likes blonde guy. She's really happy with him, so she cannot be what the rules call girl B. Same for hat girl, she really likes eye patch guy, so she cannot be girl B. Now this is where it gets interesting. The black-haired girl really does not like the black-haired guy. He is bottom of her list, even though they're matched. So we're going to label her girl B for the time being, and highlight that rule at the bottom there. So now we've found a potential girl B, we now need to find a guy A. A guy A who likes the black-haired girl more than he likes his current match. Looking through the list of guys, we have blonde-haired guy, who likes black-haired girl third most, but he prefers the eye patch girl over her, so it can't be him. Looking at black-haired guy, they're matched, so it can't be them, because guy A and girl B cannot be matched. So we found moustache guy. Now we are going to label guy A, because she, the black-haired girl, is top of his list. He really likes her. He likes her more than the blonde-haired girl, which is on the right, which is what he is currently matched to. So that's guy A likes girl B more than his current match, and they're not matched. So that's all three rules fulfilled, so this matching is not stable. So, for the algorithm itself, you start with the lowest unmatched male, and go through his list of females in order, proposing to each of them in turn. If the one he proposes to is unmatched, or if she prefers him over her current partner, then those two become matched, and any previous partner they had is now unmatched. If the proposal is accepted, move on to the next unmatched male, and then repeat until you run out of men and they're all matched up. And here I've got some pseudocode, sort of Python-y, to put it in a different way. This wouldn't quite work because, first of all, I haven't built the males and females object. Even if you did build them, this wouldn't exactly work because the .unmatched wouldn't update every time we went through the loop. But it gives you a better idea than this wordy explanation here. So, Time for an example, because that's the best way to learn these things. So we'll start on the first unmatched guy, which is blonde dude up here. And he's going to propose to the eye patch girl. So the eye patch girl, if we look along here, is unmatched. So she accepts his proposal, and then we note it up here in the guys' ranking, and we also note it down here in the girls' ranking. Moving swiftly onwards, we're going to go down to the black-haired guy. He is going to propose to the black-haired girl. The black-haired girl will of course accept because she is unmatched. And then mustachio guy, he proposed to her, the eye patch girl, and this is where it gets a little bit interesting again, because she is already matched to the blonde dude. So what she's going to do is she's going to dump him. So that you see here, we've got the red here and here, and she's going to partner up with the mustachio dude. So he's quite happy when the blonde haired guy's upset. So on to the next unmatched male, and that is the blonde guy, because he's no longer matched to the eye patch girl. So he goes and proposes to the blonde girl. Blonde girl is not matched, so she accepts. And then we're on to the eye patch guy. Eye patch guy proposes to the blonde girl, but she's already matched to the blonde guy. The blonde guy, however, is lower in the ranking than the eye patch guy. Blonde girl dumps him, unfortunately for him, second time in a row, and goes with the eye patch guy, as we can see here. The blonde guy thinks third time lucky, I'll go for the black-haired girl, and the black-haired girl is unfortunately already matched to the black-haired guy, but she prefers him to the black-haired guy, so those two split up, and now the blonde-haired guy and the black-haired girl are together. Black-haired guy is the only unmatched guy, so he's next. He proposes to the eye patch girl because she's next up in his ranking. He won't propose to the black-haired girl because she's dumped him already. Unfortunately, she prefers Moustache Guy over him, so he gets rejected. So the big red cross for him. Still, he keeps his chin up, keeps going on, and proposes to the blonde-haired girl. But unfortunately, the blonde-haired girl prefers her match over him as well. So he goes up to the only remaining girl, the hat girl, who sadly has not been proposed to at all so far, and proposes to her. Being unmatched, she accepts. And that matches everybody up nicely, and the algorithm is complete. Now we're going to check to see if there's a stable matching. The blonde guy to start with. He prefers both of the blonde girls over the black-haired girl, but the blonde girl prefers who she is currently matched to, and the eye patch girl prefers the moustache man over him, which is who she is currently matched to. As for black-haired guy, he prefers anybody else over his current match, but the blonde girl prefers her match over him, and the girl with the eye patch prefers her current match over him, and the black-haired girl prefers her match of the blonde guy over him. So he's, although not very happy with it, in a stable relationship. Now for the moustache man, he is matched to the eye patch girl, who is his top match. There's nobody else he likes more, so he cannot be the guy A. As for eye patch guy, same applies to him. He couldn't be happier, therefore he cannot be part of our unstable pair. So without any guys to be A, there can't be any corresponding girl Bs. So our matching must be stable. Looking at the computational complexity, the big O notation of this algorithm, we can assume that each proposal takes constant times, that's O1. There are n males and n females. Each male will only propose once to each woman. So at worst, a man will propose n times once to each woman. There are n men making n proposals at worst. Is n times n proposals in total, making this algorithm ON squared. Looking at a different way, we have the first loop here, for guy in males.unmatched. This runs ON because it runs for n males. Inside this loop, there is another loop for girl in guy.preferences, goes through all of the girls in order. That runs through n girls. And inside that, we say that this bit runs in constant time, so we've got 1 times n, that's ON squared, which is the big O notation.